Okay, good morning, afternoon, or evening, everybody. Welcome to the Gregory G. Leptuk 4th Online Giovanni Workshop. This is your host, Jennifer Brennan. Today, we will kick off the workshop with the first webinar, NASA Giovanni Applications to Earth Science Research from Outcomes to Methods. It's 2 p.m. Eastern Time, so we're going to go ahead and get started here. What I'd like to do first is go over a few logistics related to today's webinar. During today's webinar, audio is only available via computer. Our speaker for today is currently in the field, so we recorded his presentation several weeks ago. We will include, the introduction now is live and commentary during the 2 demos, as well as the live question and answer period at the end. While this content has been pre-recorded, again, the Q&A will be live. So if you have any issues or you have any questions, what we'd like for you to do is enter those into the Q&A pod, and you'll find that located on the right-hand side of your screen. This works like a chat. The Giovanni Workshop organizer, Dr. James Acker, will address questions for Dr. Jury at the end. As far as timing is concerned, today's webinar will be 1 hour long with 45 minutes allocated to the presentation and an additional 15 minutes for the question and answer period. Once the presentation is complete, we will transition to an optional set of polling questions. And normally we'll give these questions 3 to 4 minutes or so. And then from there we'll move directly into the Q&A period. And depending upon the volume of questions that are received, we will extend the Q&A period an additional 15 minutes from end time for those of you who may wish to stay on the line. All right, during today's webinar, you'll hear from 2 speakers. The first is Dr. James Acker, a senior support scientist at NASA's Goddard Earth Sciences Data and Information Services Center, or JESDISC, and that's located here at Goddard Space Flight Center. He will provide an introduction to the Giovanni Workshop. Our second speaker is Dr. Mark Jury. He is a professor of meteorology within the physics department at the University of Puerto Rico, Mayaguez. His presentation showcases how he and his students have used Giovanni in conjunction with other data products and outputs in research. With that, what I'd like to do now is turn it over to Dr. James Acker, who will provide an introduction to the workshop and go over the agenda for the next 3 sessions after today. Dr. Acker?
Hi, Jennifer. Can you hear me?
I can, thank you.
Good. Thanks for the introduction, and I'd just like to add that I'm not an expert on what Dr. Jury does. He is a very prolific author and an avid user of Giovanni, which is why I invited him to give this talk, and he's currently as Jennifer mentioned, he's currently in the field in Africa. So I was very glad to get his participation, and you'll see some of the things that he can do with his students with Giovanni. Just briefly, we'll have 3 more webinars in the series of the Gregory G. Leptuk Online Giovanni Workshop, and you can see the schedule here. The next one, we're skipping the following week because of the July 4th holiday week in the United States. And then on July 10th, we'll have 2 presenters from the RSET program. They use it for professional training. And then on the 17th, I will be speaking about the current status of Giovanni, a little bit look at what the potential is for the future, and then the images for the Giovanni Image Hall of Fame. And this will be I believe the 3rd time we've done that. And there's some really fantastic images that have been done in papers, so I think you'll like that. And then the last, on July 24th, we have Dr. Guido Cervone, and he's from Penn State, and he has used Giovanni and a statistical analysis package with his students. And so we're covering a good gamut of research science and applications and a good overview of what Giovanni can do, and then finally how it works in undergraduate research. Okay, so now Jennifer will start the recording. I will note that when Dr. Jury did his recording, Giovanni was experiencing at a few times particularly high demand just when he was doing the recording, and so we have a couple of recordings of what he was trying to do that we will show at the appropriate time. And I'll talk about that just briefly when we do that. Okay, Jennifer?
Okay, that sounds great. Thanks so much for the introduction, Jim. At this point, we will begin today's recording, and as Jim said, we will stop A couple of
I
times we can
suppose,
go
and so I just
through
wanted
the
to
Giovanni query.
again
Great, thanks everybody.
introduce myself. My name is Mark Jury, and I'm a professor at the University of Puerto Rico in Mayaguez, and I do earth science research, and I'm going to show some examples today of the way that I collect information and look at it between different websites, but mainly using the NASA Giovanni website. So, for example, here I have an analysis I'm showing of the statistical variance from another website, which is giving me ocean information. And I have the upper right panel is showing variations in salinity in the region south of South Africa. And on the bottom panel on the right, so that's F, is the, let's say, hydrological influence from the ocean side. But this particular model doesn't show land information. So now I want to look and see whether the salinity near shore, which is showing the variance, is being affected by runoff. Where is the runoff greatest, and that type of thing. So we will go to the website here of NASA Giovanni, and I've already called up, let's say, a time average map up here. I have the date range for a particular case where we have quite a bit of runoff we're expecting to see. I've put in a map. It's an approximate boundary that's focused on that area of southern parts of South Africa. And I have two, let's say, parameters that I've called up from the FLDAS VIC hydrological model, which provides subsurface and surface runoff at monthly resolution. I'm only going to use 2 months just for demonstration purposes, although for research I would take longer time periods in most cases initially and get a fluctuating time series. So I'm going to plot that information there, and while that's working in the background, it's creating those two maps just for those 2 months. I'm going to look at some other information on NASA Giovanni. For example, some of the work I do is associated with hydrological resource development in places such as Ethiopia, Kenya, Zambia, and so on, looking at the possible feasibility of hydroelectric schemes and so on. In those locations, there are generally dry climates, but there are high mountains, and so those can provide, sources of rainfall and runoff. And so, busy, doing research and consulting work on that. In some cases, for the World Bank, and other cases just for research purposes. And in looking, for example, here, I'll go back to the menu in a minute, but I'm looking at Ethiopia. You see the border of the country here and the grid points. You can see where the cursor is, it's showing latitude and longitude. And here I'm looking at the evapotranspiration from the land from the MIRA model. So that would be telling you up at the top here this information. And it's just for a period of June to August 2015. So it's a 3-month period when, it's summertime and they're getting rainfall there. So I'm comparing, in this case, the evaporation over land, which you can think of as transpiration, with the vegetation fraction that's assimilated by the MIRA model, and also the latent heat flux. So the latent heat flux looks similar over land, over the highlands and interior regions. But if we go over the ocean here, this is the Red Sea, we find that there are higher values of, let's say, surface evaporation over the ocean that is not being picked up, of course, when we talk about transpiration, which is a land variable. So the idea is then we're comparing the total fluxes in this case from the land-only fluxes in this case. So those are just some of the interesting features that you can gain from looking at, in this case, the MIRA model outputs. Let's go back to the user input in that case and see how I got to that. So what I did was in the NASA Giovanni website, I went to my particular time period, 2015, June to August. I put in my coordinates there, and I then went down and I ticked off evapotranspiration and latent heat flux. I also then went down further in the menu. I put vegetation. I said MIRA 2 model there, and I also went to the temporal resolution, said monthly. So for the purposes here then, after going through all those sub-menus, if you like, then you end up with a relatively small group of variables here. And if we turn one of these on and off again, it'll probably bring up the menu again. While that's busy, I want to demonstrate something else. Okay, so some of the other work I do is to supervise students at the university in their fourth-year research projects. They have an individual study project, and in this case, one of the students decided they wanted to look at carbon monoxide concentrations over South America, and so going through her paper there, what we are looking at is the first thing that would be done would be to look at the spatial map averaged over, let's say, a long period of time that we have satellite data or model data, and ideally we would restrict the period of analysis to the period when we had satellites that were measuring and not go to the period prior to that when the satellites were not available, even though there might be model data based on inventories and things like that. So we can see in the analysis that we have Moffett and Ayres that both are able to measure the vertical structure of carbon monoxide, and so we create a map in NASA Giovanni. We have to be careful to understand how the satellites are working. I'll show you a little bit about that in a minute. And then we look at the low-level, let's say 900 hectopascal carbon monoxide concentration. Carbon monoxide being a greenhouse gas which is emitted in the process of biomass burning. So by having that map, then we can create a target area in the region of high emissions and high concentrations of CO. We can also analyze the vertical structure of the emissions, in this case south to north. On the right-hand side where my cursor is, it's from east to west. What I want to do then is look at how that structure there varies, looking using Moffett satellite as opposed to the Ayres satellite. So we're going to do an Ayres equivalent map in NASA Giovanni. Just a few things to refer to also is to suggest that if we look at other corresponding variables such as MODIS, aerosol optical depth, we can see similar features in that product, which is not having vertical resolution. It's a tropospheric average, but we can see very similar concentration distributions there. And we can also see, using different websites, where the fires are located, using, again, a MODIS satellite. Also where the lightning is detected, also by satellite. And we can look at some of the vertical structure of the emissions in that same area, and also look at the seasonal cycle of lightning. So these are preparatory to understanding some of the features that we're able to find using the NASA Giovanni website. In that index region, we have a time series here. What I'll do is I'll go to talk briefly about where that came from. So first of all, we're talking about recreating this image here in the bottom. This is now in an Excel spreadsheet where we're looking at vertical height versus longitude across South America. What I have superimposed on the NASA Giovanni shaded values, which is the AIRS CO, is the winds from NSIP2 from a different website, and also the vertical profile of the topography. As we look a little bit higher up, we see that we can look at the AIRS Moffett comparisons, and in the case here, we're looking at the AIRS radiometer sensitivity, and we're noticing that it has pretty high sensitivity in the mid-troposphere, but it doesn't have channels that pick up the profile, in other words, lower down and higher up as well as does Moffett. So these are the Moffett sensitivities on the right-hand side. So again, as you're exploring data in NASA Giovanni, you have to understand it a little bit and make sure that you're not just blindly, downloading data that you have no idea how it works. That time series that I'm showing you in the outcome was constructed by downloading data from NASA Giovanni. So here, is the spreadsheet. It's just an Excel spreadsheet where we have the MIRA 2 model data for that box region there in the south parts of the Amazon. We also have the Moffett data for that region. We then compare the two in a time series. So there's the time series that I just showed you. If you understand, of course, that MIRA is the NASA reanalysis that assimilates all the satellite and surface emission data, and so should be accumulating a number of different variables and inputs in addition to Moffett. But it's also good to compare what the model's seeing with the raw satellite information. Not very raw in this case, it's probably level 3 gridded and quality controlled and interpolated. So we can see, for example, here we have a peak in 2007, and the peak generally occurs in the July, August, September, October period, that particular month, September 2007. So there was a rising trend up to that point, and then it sort of decreased again. So there's not an overall large trend in that data set, and we are obviously able to then identify, in this case, the season and the location. So we have the location here, and we have then the seasonal cycle of that here. But we can also import that information to another website, which will give us the mean seasonal cycle, and also show us its variations over time. We can then focus on, let's say, July, August, September, October, with particularly high values, often in September, at that time of the year. We can take that time series and also import it to other websites where we can do point-to-field correlations. So this just happens to be the correlation of the CO in the southern Amazon with the sea level air pressure. And we can see we don't have a signal over land and in the Atlantic, but we do have a pressure signal in the Pacific and the Caribbean, which is inverted. So when the CO is high over the southern Amazon, based on the NASA Giovanni data, then we can see at the same time we have higher pressure over the region west of Ecuador, and we also have colder sea surface temperatures there. So the idea is to download the data. Here it is here. There's the years, there's the months of information, and comparing the two. Then we upload the average of the two, and we then can do correlations with that. Let's go back to the NASA Giovanni website, and what we're going to do then is we're going to create an average over a vertical slice This for July, August, September 2007. We have our latitude and longitudes plugged in here. So we're going from 90 to 30 west, and we're slicing and averaging over 15 to 6, and we're doing a vertical cross-section of longitude versus pressure. Just to change this a little bit, I can go and also include October for that year. So we have then 4 months, July, August, September, October. And we've identified that that is the particular one we want to use. For this purposes, I won't be going for daily data, I'll just be using monthly data. And in any case, daily data might also have gaps in it because it's relying on a single satellite, whereas if we're using mirror data, we might not have those gaps. I'm going to plot that data, and in the meantime go back and see where I was over here. So this was now looking at the transpiration over land, the total energy flux, again using just the mirror model, and we were looking, just sort of going backwards from the result that I showed you earlier to the menu to show you how I was considering that. The transpiration and the latent energy flux are almost the same in terms of their pattern, but they have, of course, different units. The one is millimeters per second, so they have a large number associated with it, whereas the total latent heat flux or energy flux would be in watts per square meter. So those can be resolved later on. If I go to these results, which I was working on over Ethiopia, one thing I can show you is that, for example, there's ways in which you can adjust the plots to give, let's say, a different appearance. So let's just look at that. Let's say that I want to focus more on the highlands where the greenness is higher, and look at that fraction. So I'm just going to replot that by lifting the minimum here, and that will reduce the area of green coverage in that particular diagram. So it's just a cosmetic change that's being done there. So now we have our subsurface and surface again here. I'm going to turn off the subsurface, and I'm going to plot this data here. Again, this is a 0.25 degree resolution data set. I'm only looking for 2 months average, and I'm going to plot that data there.
Okay, at this point we're going to transition to one of the demos that Dr. Jury had an issue with during the recording. So Jim, if you could speak to this recording, that would be great. Thank you.
Right. This is just a screen capture, actually, of the Giovanni session that Dr. Jury was trying to initiate that ran into a high demand event on Giovanni. And the nice thing is when I recorded it, it shows how fast Giovanni can be. So here it is right now. You can see the region. And one thing that Giovanni does is you can see the progress that's going on as it does its analysis. And then I changed it to make it a little bit more visible, what Dr. Jury was trying to show by changing the scale, the color scale for the color palette. And note that when this is done, the color scale will be different for the map, and the palette will be shown on the right side. Okay, that should be the first one. So now we'll return briefly to Dr. Jury's presentation.
See how that.
I'm sorry.
If we reduce this, we
this
can
is the second.
reduce our slice cross section to focus mainly, let's say, on this minus 90 to minus 30. So those are the
I'm sorry. This is the second part of the
minus 12
presentation. This
to
is his
8
carbon monoxide
south
slices.
region.
It was also slow. And so now you'll see the
All
vertical
the
profile
there,
of carbon
we're going to be
monoxide
looking at
using AIRS
some
data, I
other
believe.
information on this.
Yeah, now this is the vertical slices. And AIRS has data from 1,000 hectopascals, which is close to the surface, or actually below sea level, up to 10 hectopascal. I think 1 actually, hectopascal in the upper atmosphere. So this shows the cross-sectional map of carbon monoxide. Okay, thank you, Jennifer.
Visualization of the greenness fraction, which is the model's, let's say, the simulation of satellite visible band information is coming up here. So what that's done now is it's lifted the bottom of the scale that I've done earlier. It's just lift the bottom of the scale to be more focused on the area of interest. So again, it's filling in the information here to be able to focus more on the highlands because it's delivering that information. So here we have the information. So the question might be, how do we want to gather that data? Do we copy the image here? We could do that. Or we could download it over here as a PNG, GeoTIFF, KMZ file. And depending on your applications that you have on your computer, the easiest one for me to demonstrate now, which isn't necessarily high resolution, is the PNG. But I'll click on that, and that will then load the PNG file and automatically bring up the application which will show that. So we'll have a look at that. Okay, so in the meantime, we have this now, and maybe I'll reduce again the number of months here so that we aren't asking for so much information. So we have August, September 2007. We're going to plot that. It's a vertical slice. There we go. Okay, so now the Giovanni server has delivered the greenness fraction. In this case, I've requested a low resolution PNG file, which is not something we publish, but it's something that could be used, let's say, as a placeholder in an Excel spreadsheet. Later on, you would then go and get a higher resolution, let's say, GeoTIFF version of that if you were planning to use that in a report or in a publication. So this could be taken You can obviously copy that and move that around. I've just grown a little bit, and I've opened that in the Windows Photo Gallery to be able to see what it looks like. So I'm relatively happy with that. It's cropped to some extent the picture, and it's put the color bar next to it by asking for the PNG. It's also told me what all the details are, so when I make the caption in the report, I have that. Of course, I crop that out later. And, it's picking up the greenness fraction at the resolution of the Mirror 2 model, which is 0.5 latitude by 0.625 longitude. There are higher resolution products in NASA Giovanni that could be used to do the same thing, and this is just taken a mix of different satellite visible band data and working with that. We go back to the request. It's still pending, so at least it's moving along, and we have then made some progress here. Be able to download this information. There's other options as well. What I think I will do then is to demonstrate, go back to user input, and let's say demonstrate another feature here, which would be the downloading of, let's say, time series information. So, for example, let's say that I'm wanting to get time series, and I've already got, I go over the time series like this. I say I want area average time series. I want to then reduce my area and increase my time. So I'll do that. Let's say that I'm focused on just a few years, so 2013-01. Haven't got any variables requested at this stage, 2018-12, and we'll reduce the area here. It's possibly better to make sure you get your variable first. And so what is it that we would like? Well, we can stick with the evapotranspiration. And so we have a long list of variables in the menu here, which is a bit overwhelming. And so what we might like to do then is decide what is our platform that we want. And the Mirror 2 model monthly would be easy to demonstrate. We're calling that, and that will then provide a list of the variables that are only in the Mirror 2 model, but there's a lot of them. And we have, I think, monthly, hourly, and so on. So the next thing would be to say, well, let's just restrict our analysis to the temporal resolution that will be monthly. And here now the menu shortens, and we say monthly. We've got our platform and our resolution in time, and we then have all these variables still. So we could then say go to evapotranspiration is only 2 then. And that starts to limit the number of variables down to a relatively easier level. We've got these already, and so let's say that we want to change now and not have greenness fraction, and total latent energy. Let's just get evaporation from turbulence by itself. So we know that evaporation is able to be fluxed into the atmosphere as a function of the moisture of the surface and the speed of the wind, which would then create turbulence. We're going to use an area over, let's say, Ethiopia, which would be 35 east. It'll be 5 south. We use 40 east, so we're focusing on just the highlands, and we have, let's say, 14 north, 5 to 14 north, 35 to 40 east. So we have to be careful to make sure our bounding box is got the right, and in this case, because we're in Ethiopia highlands, we have everything positive. We don't have any negative values there. Okay, so now we're asking for a time series with this 5 or 6 years here, and it's going to be averaged over that area, 5 to 14, so that would put the Nile River catchment, the Blue Nile River catchment right in the middle. So we'll plot that, and we should then see a time. Let me go back to my spreadsheet and show you where we had gotten the information. So this was a NASA Giovanni product. There was our time series. Over here we had, again, NASA Giovanni products that would be, in this case on the left, the Modus Terra AOD, and that just happened to be in September only. And then over here we have the Mira 2 black carbon. You can see the two are corresponding quite well, with the exception of Modus showing a feature, let's say, over the mouth of the Amazon, which we don't see in the Mira 2. So Mira 2 is the model. Modus, of course, is the satellite. Here we have data from other websites where we're looking at the same map, but we're looking at winds, and we're looking at winds in the 925 to 600 hectopascal level. So that would then be the winds that are actually, ejecting the smoke in different directions. That is from the biomass burner. Let's look again at some of the NASA Giovanni products that has been downloaded. So what I'm doing is taking those products and putting them into a spreadsheet. In this case, we're comparing, for example, the Moffett product on the right with the Ayers product on the left. And both of these have the same topographic profile, and they have the same winds, and the only difference is, of course, the satellite. Obviously, the model, something like Mira, would have to resolve the differences in the way the satellite is viewing. And so, to some extent, Ayers is giving a high value in the middle of the troposphere, whereas Moffitt's giving higher values near the surface where we have the emissions, and also in the tropic pause, or just below the tropic pause up here. So, to some extent, we could say that neither is exactly true. Both are a function of the satellite radiometer, and it would be up to the model, something like Mira 2, to resolve those differences and to provide possibly a compromise between those two that would then be more relevant. You see, I'm also downloading other information from other websites, as I said before, that would then be complementary to this. This is now, instead of looking at a peak case, this is just looking at a long time series from 2001 to 15 of the Moffett CO. In this case, we're looking at the south to north slice rather than the east to west slice, and that's showing, again, with overlays of the topography and the mean winds. So the mean winds are showing, let's say, kind of a Hadley type of returning circulation there, which is lifting the biomass burning smoke emissions through the column and up towards the north and to the south mainly. The page where we had all the time series, you can see the time series here is like this, and we're able to see again the annual cycle. We can plot it from our spreadsheet, or we can import it to another website and get that. One of the ideas is to trace backwards the influence of the CO on climate change. And so we've talked about interannual variability, and also there's a climate change feature. So again, this is now that period of high emissions in September 2007. This diagram is from NASA Giovanni. Then we have ancillary data from other websites, and this is a vertical slice from Calypso, which is flying north-south through there and measuring the aerosols backscattered. And again, it's slicing through here to see the vertical structure, and it shows a very sharp edge. The smoke emissions are mixed upwards to about 4 kilometers in that region. It's a slice through here. And then we can also do trajectory modeling where we have a virtual fire and we then program it so that we can see which way the emissions are moving. So we're comparing that. Another feature then is to then look at trends in the temperatures and winds and so on. In this case, we're seeing that in the region where we have the fires, which is around 10 south, is where the mean peak of the fires are. We also see in that region, in the troposphere, higher rates of warming. And we also have a wind trend, which is lifting the products and sending them slightly forwards, but then lifting them. And in that axis where we see that lifting, we have the higher rates of warming and trends. In a different website, again, we can see the high values of surface land temperature changes and in terms of the rate of change over the last 2 decades. And we can see that in the region where the fires are in the southern Amazon, we have higher rates of change of 0.1 degrees Celsius per year, and over the Andes even higher in regions that are not necessarily having biomass burning, but that are at higher elevations. So I'll end there for today for the presentation, and I've managed to be able to demonstrate some of the features from NASA Giovanni that I hope you can find interesting. Thank you very much.
Okay, thanks everybody. At this particular point, we will transition to an optional set of polling questions. We'll give these questions just a couple of minutes or so, and then from there we'll move directly to the Q&A period. So thanks so much. We're going to give these couple minutes, and then we'll transition to the Q&A.
Okay, I'm ready to go. If I think we have some good questions and some good topics for future webinars to look at.
Absolutely. So Jen, the first, let me actually get to.
Yeah, don't forget you can follow them on Twitter. NASA Earth Data is what Jennifer is associated with, and we also have, as you can see, NASA GS Disk and NASA Giovanni.
All right, great. So the first, it's really more of a comment, but I'd like your feedback on this. In Giovanni, we can download the data of different USA states by selecting the desired state shapefile, but this option is not applicable to other countries' states. It would be better if we have these options as well, and I don't know if that's something for future development, if you could speak to that quickly.
It's possible, but it's also difficult because the shapefiles that we got were from some easily accessible databases for a global database of watersheds, which are a single classification, or obviously the United States or countries. And one of the problems with states or provinces or cantons or whatever else they are called in other countries is that they are so different. And so we even would have a problem with potentially resolutions of states, in particular small countries, being smaller than the resolution of the data in some cases. So it's a case-by-case basis. There is a lot of potential in Giovanni, as I'll allude to in my talk, without a lot of detail, of doing things like this as we change the way we're going to develop it and work more with the community. So one potential idea that can be out there is that for, shall we say, larger countries, essentially, with larger areas, for example, Canada, we could use the provinces. Australia just has a few areas. It may work, but again, it would almost have to be on a case-by-case basis with the country, and then you'd have to put each database into Giovanni. So it's not a small task. It has been requested before, and we will have to see where we are in the development and with some of the other priorities that I'm going to talk about in a couple weeks, as whether or not we could do something like that.
Okay, great. Thank you, Jim. The next question is, are you going to add high-resolution products to Giovanni? We cannot find all NASA products in Giovanni.
Okay. Well, one thing, and when we do the introductions to Giovanni many times, we'll point out what Giovanni uses is mapped, gridded global data in most cases, or it's in some cases a higher resolution is available for a region, which is, for example, the FLDAS, which is the Famine Early Warning System. That's the F, Land Data Assimilation System. They have done some higher resolution stuff, and there is actually some high-resolution FLDAS products that have been expanded globally at 0.1 degree resolution, but only at a monthly timescale. So there are products there, but if we can only use what we have available as a mapped data product. The other factor is we also have other tools for our data here at the disk that work with the level 2 data, which is the higher resolution data. We actually have a subsetter that allows you to set the parameters, the region, the time period, and you can, in cases where you have a data product with multiple data variables in it, you can also specify the variables. And so that allows you to look at some of the data that's in Giovanni as a global gridded product at higher resolution using the level 2 satellite SWAT data. So we have those options. Obviously, we're only one data center. We don't have all the other data centers that high resolution data might be preferable for. So, and I will say some of the other data centers have some great tools as well. So we can apply Giovanni to what we have. Okay.
Okay, great. Thank you, Jim. The next question is, what product that's available within Giovanni would you recommend to track the effects of biomass burning?
That is a good question, and one thing I will point out before I do my best job of answering it, there are also good references to people that have done things like this, and you can also look in there and see what they've done just to make sure you're following what the scientists have done and published. I would recommend several. Aerosol optical depth, which you saw in Mark's presentation. Carbon monoxide, again, which you saw in Mark's presentation. Nitrogen dioxide is a combustion product. It has been used many times, and it's very good at really looking right where the fire is and the effects in the immediate area. There are several products in MERA 2, such as black carbon. I believe there is a biomass aerosol. I'm not sure of that. So it's a matter of searching, and if you're not sure of what you found, then ask us a question, and we can route it to the data scientists that we have here at the disk to really find the best data product for your needs. Okay.
All right, great. Thank you, Jim. So the next question, and I don't think you have any GRACE data in Giovanni, do you?
The only thing that we have for GRACE data is a hydrological product, and there's 3 variables. Off the top of my head, I think one of them is subsurface reservoir water. It's basically based on the gravity information from GRACE that gives you the amount of water.
Right, thank you. So, and I responded to this user that GRACE data can be accessed at our NASA Physical Oceanography Distributed Active Archive Center, and I included the link in my response. So that is where really you would be able to find global GRACE data products and the various level products. All right, the next question is, do data products need to be modified in order to be made available through Giovanni?
Not sure what modification means. In order to be used now, they need to be a mapped global, as I say, mapped global gridded product, or at least a regional gridded product that we have a few. So that's about all.
Okay, thank you, Jim.
And if I see it's Vishal, if you have further questions, I can probably go into more detail back and forth by email. So you can give my email address too if you want.
Okay, sure, no problem. All right, so the next question that we have here is, how do the aerosol optical depth values for MERA2 model and MODIS Terra compare?
That's a good question, and that's something that I'm working on due to some user input, and we will see if we can find some literature in which they have been used. MERA2 does a lot of analyses and a lot of comparisons to actual satellite data just to make sure that their model is working, and so we can talk to the MERA2 group as well and see if we can find good answers to that. Right now, it's not something that I've actually done. So we'd have to see what the scientists have done.
Okay, thank you, Jim. The next question is, can you add an option for adding data manually by the user and then get the output from Giovanni?
This is something for the potential future of Giovanni, and it's something we're looking at in terms of where we can go with Giovanni as a single server here, perhaps expanding it to a more general application. And that's about all I can say right now because we're still working on how that would be done. In 1 or 2 years, it may be something that's possible.
Okay, thank you, Jim. The next
Okay.
question has to do with, could you say a few words about how you transfer HDF data to Excel?
Yeah, actually, I've written a how-to, and it's a way of taking the map data that is actually, and we say HDF, but we no longer have HDF data as an output. We have, I want to say, I believe it's NetCDF, and that is what you can get as the data output from Giovanni. And then I have written a tutorial, and basically you use a free NASA software, extremely powerful visualization software as well, called Panoply. And you can actually take the data from Giovanni and turn it into a CSV file that you can then put into another application. The one thing I have written, the how-to tells you how to do it in an Excel spreadsheet and how to convert the output in the format that Panoply gives you into a format in Excel where you have latitude, longitude, and the data value. Now, one thing I will say is that you can easily get the time series output from Giovanni and put it as a CSV and put it directly into Excel or anything else that you're working with. So time series is really easy to work with. The map data, you have to basically do a transformation in order to make it easy to use.
Okay, well,
so
now
I can, you
okay,
can give me my email address. Yeah, give him my email address, and I can also point him directly to that how-to and how to do it.
Yes, that is exactly what I was about to ask you, Dr.
Yep.
Acker. Where can one find this wonderful tutorial you just mentioned?
On the NASA GS-DISC website, but rather than search through all of them, I can give him the link to the one that he wants the most.
All right. Are there any additional questions? Anybody? So something that I'll do in just a moment here, I'll provide a link in the Q&A pod for the data recipes and tutorials that can be found on the NASA Goddard Earth Sciences Data and Information Services or the Goddard DAC website. So I'll put that in the Q&A pod so you can sort through potential recipes you may be able to use in the future for your research or
Right.
application.
And they can follow up with us too. And even sometimes if people ask us something that would be nice to do, we look at it and we say, okay, yeah, we can write a recipe and tell them how to do that. So recipe,
And
we also
so
call them how-to documents.
your email is
G, James,
Acker?
yeah, G for Gardner, .acker@nasa.gov.
All right, everybody. There you are. I'll contact
Yep, that's
Dr.
me.
Acker. Are there any additional questions?